Have you ever wondered how deep tech companies actually start? Well, we were too.
So in this podcast, we'll be interviewing scientists and entrepreneurs that have taken their ideas out of the lab and turned them into startups. I'm Antonia.
And I'm Christina, and this is Startup the Science. Hey there, and welcome back to another episode of Startup the Science. Today we have Alex Reed from Fluence Analytics. And oh boy, I think from now on, if there's someone super not technical like myself who is interested in a new podcast, I might actually send this one to them because Alex has a gift for metaphors. And this is what we learned in this podcast episode. He makes a really good example using cake. And not only am I a baker of cakes, I am a consumer and an eater of cakes. I'm a big fan of cakes. And he uses cakes in this episode so perfectly that I completely understood his technology. Not completely, but I understood the gist of it. Most of it, let's just say. I understood how it kind of works. So if you're a fan of cakes or just, of real-time monitoring solutions for polymer reactions, this is definitely the episode for you. On another note, though, Alex is a really cool dude. He is from the Gulf Coast of America, New Orleans, to be exact. And what a joy it was to talk to him. He's just so pleasant, so easy to chat with. We heard from Alex actually just out of the blue in our email. So if you are a technical, scientific, advanced materials startup, do the same as Alex. Reach out to us and maybe you'll end up on our podcast. I mean, we had never heard of them before and now we do. And now he's, somewhat part of our network and we would love to keep in touch with him. So contact us. Our email will be in the description and we'd love to have you on our podcast. Anyways, with that being said, I hope you enjoy this and I hope you have a piece of cake at the end of it. Enjoy.
Hi, Alex. Welcome to our podcast today.
Thanks for having me.
So you're we're calling you actually, but you are in the US. Do you want to tell our listeners where in the US you are?
I am in New Orleans, Louisiana, and in the Gulf Coast.
That's very exciting. You're definitely the first startup we have from there. And tell me a little bit about why you're based there. Is that because, as far as I remember from a previous conversation we had, your startup is a spin-off from the university there. Is that right?
Yes, that's right. Yeah, we spun out from a local university, Tulane University. And I'm surprised we're the first Gulf Coast startup because there's a lot of chemical industry in the Gulf Coast of the United States. So we're also very well located with a lot of our customers nearby.
So tell me how it all started. When did your company start and what happened before that? So most spinoffs have a story that goes way before the actual company started. So how was it in your case?
Yeah, I mean, you're very right, especially spinouts. The incubation period can be quite long because it's based on research and intellectual property. So we're very similar in that regard. We had a research center at Tulane that was very focused in this area of polymer reaction monitoring, characterization. And funny enough, the person that runs that center is my father. So I actually grew up working in the lab as a little kid, 12 years old, and was running instruments and taking chemical inventory, things like that. And then I got pretty excited.
Is that legal?
I wasn't getting paid, so it made it okay.
That's even worse,
Yeah,
I feel.
right?
Okay.
It was fun. And then over time, just became very interested in that. And so that's, how I got involved with it and why it was working there at the center. And then, to answer your question on how we got started, that research was being done, patents were developed, companies were funding the work. Working with all these chemical companies who've been funding the work. And then we would get to the point where we did this very cool stuff in the lab. Hey, we monitored your special reaction. And then they'd say, well, that's nice. Can you do this in my plant or in my R&D facility? And then as a research center, we would say, no, we're a research center. And so we got that question enough times that we said, well, maybe this is a product, maybe because so many people have asked us that question, that we should look into this as something to spin out.
So when you say this is a product, the product would be the analysis you were doing at lab scale, but that couldn't be scaled out and taken, for example, to a production plant. What exactly is this analysis, or how does that process look like in the lab? And then how was it scaled up into what you do now?
What we have is a real-time measurement system, and it's a fully integrated piece of hardware plus software. And so I think the easiest way to think about it for the layman is, think about baking a cake and think about following a recipe every time. And so, maybe you follow the recipe, a few things are off, and then all of a sudden you've burnt the cake, or maybe it's too dry. And so in the chemical industry, especially in a lot of these production reactors, you have a similar process. You're following a recipe, but there's so many variables that change. You have temperature, you have operators changing, you have feedstocks changing. So imagine if you were trying to bake a cake where all of your inputs were constantly changing and still trying to get that perfect cake. And so that's kind of like what we're doing, just applied more in the chemical process, which is, we're able to monitor what's happening in that cake in real time, so that they can understand exactly what might need to be changed to make sure every time they have that perfect best cake.
Right. So I think we can relate to that metaphor easily without being chemists, because we've been baking a lot because we've been stuck at home.
That's right.
And so it's good to know that we can extend that outside of the kitchen world. So basically, if I think about it as a non-chemist, why this would be great is, first of all, you get a better cake, probably not a cake, but whatever it is that you're working on. And then your process also becomes cheaper, right? Because you want to avoid wasting materials, consuming energy, and processes that won't lead to the result you want to get. Can you tell me some other benefits of why using real-time data in chemical processes would make a lot of sense?
Yeah, so I'll tell the technical version of the same story. And basically, if you look at the industry and trying to optimize several different variables, like you said, you're trying to minimize waste, you're trying to improve quality, and you're trying to standardize quality across all your facilities generally, so that when you sell product A in a facility made in the Gulf Coast, it's the same as product A made in Germany is the same as product A made in China. Having that understanding in real time of what you're making and being able to control it gives you the ability to optimize all of those variables. And so for us, that was the big driver is, can you reduce cost? Can you reduce waste? And then future stuff would be, because you have this real-time information, can you make polymers that you've never made before? Because you have this, a lot of these more complex chemistries, you need better control to make these processes work well. So there's that enabling component of, could we enable a new class of materials by better control and monitoring?
So in terms of what your product does, the hardware together with the software part, on the one hand, it gives you real-time data about the process you're doing, right? And the characteristics of the materials you're using. Does it also give you some guidance into what you could be doing to improve it? Or does it also give you, for example, the recipe of the cake? Does it tell you this is what you should do to get to this material? Does it do everything, or just some of these things?
Are you sure you're not technical?
No, but I've interviewed a lot of people by now. It's season 2, okay. So I feel like I can do it.
Yeah. I asked that just because you exactly understood where the future value of this technology is. So there's the short-term value, which is we could actually potentially save companies millions of dollars per reactor just to improve what's already there, like I talked about before. But what you're saying is, okay, what if we can actually tell them how to control it? Right now, we would give them a tool that gives an operator or a plant engineer the ability to optimize control. But we've already done some algorithms in the lab at just lab scale. We haven't gone full scale, where we have controlled reactions based on our data directly. So we actually typed in a property we wanted and controlled it to that property very specifically. And we actually did it with 3 different properties at the same time. And so that we think could be very powerful. Like you said, can we tell them how to control, do it ourselves, and then maybe even give them that recipe once it's built?
So if you could do all that, that sounds almost like automation of materials. So then do we even need people in the lab anymore? Or can we just press a button as the non-technical people that we are and say, I want some graphene and put in some carbon and get some graphene?
Always the question, right? When you talk about automation, there's always the concern about jobs and people, where they fit in. I think the way we look at it is this is enabling humans to do their job better. I don't foresee in the short term that all the research side and a lot of the operations side is going to be completely autonomous for a number of reasons. And even in that case, I think a better way to think about it is you can have people work on higher value tasks, because there's things that humans can do that I don't care how good the AI is, and the full spectrum of ability of a human is still greater than a very specific AI tool within a one domain. I do think those people can be used in better ways. Maybe they're creatively looking for new recipes. Maybe they're actually analyzing data or taking outputs from computers to analyze data faster. So I don't think it's going to eliminate everyone's jobs, but there will be disruption and people will need to be trained in different skills.
Right. Maybe people can make more elaborate cakes and the very basic ingredients of a cake can be made this way.
You love that example.
I just really like it. It's very understandable, easy to follow. I can go with it anywhere.
I just really want cake now.
We know what we're doing after this recording. So let's talk about some examples maybe. So from the years of experience that you have now working with different clients, I'd imagine different industries, do you have some exciting examples of projects that have been developed using your product?
Yeah, I'll give the first one, which was with a company called Nalco. So they were one of those companies that asked us, could you do this in our plant? And their problem was very specific. They had a batch, it was 40,000 liter batches that they were making. And so they were trying to optimize the cycle time on those batches by knowing exactly when each batch was complete so they could stop and start a new one. And currently, the way they do it and the way a lot of other companies do it is they have to take manual samples and actually test them at the end of a batch and then basically use a conservative recipe of time to make sure that it's completely done with all the residual chemicals that need to be reacted out.
So they go through the entire process, they have a final product, a final batch, and then they analyze to see, does that batch have the characteristics it should have?
That's right, exactly. By hand, manually. Somebody takes a sample, runs to a lab, and makes one measurement. And so what we were doing was throughout that entire production batch, we were measuring exactly those levels of that residual material and even predicting when they were going to have that reaction end. And so what we saw was that on average, it was about 15 to 20% benefit to them in their cycle time. It was huge because and the reason it was so big was because some batches went to full time, but some were done way earlier and the kinetics were highly variable. And so we saw same day, same operator, same feedstock, two very different reactions. And so that was very enlightening for us because it was our first time doing it. And so the benefit was significant. They're able to produce a lot more material out of that same asset. So that's a very clear example, like we were talking about earlier, how you save costs and time, which translates directly to dollars.
Yeah, that sounds very good. And I don't understand exactly why a company wouldn't do it. So maybe let's talk about that for a second. Are there still lots of companies, especially large companies, that are not using some sort of automation, some sort of AI in their chemical processes to improve the speed and the efficiency of what they're doing? Are there still lots of companies doing it the traditional old school way, the way I maybe remember from my chemistry classes, which are a long time ago, just going in the lab and doing things there and not having any computers around?
It's a mix. I mean, and this is what's interesting is every company is different. So the baseline is what I just described is we have a quality control lab. This is the way we've always done it. We use this recipe. We do this test. That's just how it's done. Then you'll have, in a lot of cases, process engineers, people that are looking at those data sets to understand, how things can be improved. So people are doing that with different tools. So there's tons of work being done from many different perspectives in this space because the opportunities are big. Small incremental improvements can yield pretty big dollar savings. So yeah, there is a lot of effort there, and it's all over the map. And I think where we fit in is really in this, special new monitoring that no one else is doing. We're doing certain measurements that we haven't seen anyone make. But I think to answer your question of it sounds great, why isn't everyone using your product? What we've noticed in the industry is that it can be difficult to build credibility as a startup with larger companies that don't like to take a lot of risk. The more we've built out some proof cases, the easier it's gotten on our path. I think that's a big hurdle for a lot of companies in this type of hard science, material spaces. The cycles can be long just because you have to convince a lot of people. And it's almost like every time you go to a new company, you have to convince someone new. Eventually, there is a tipping point when you have, okay, I've done a dozen of these different types of processes and shown here the dollar value for each one. Then it becomes more, they're not early adopters. They're actually just doing what other companies have done and copying that and getting all the benefits. So that's always a challenge, especially in this type of industry.
So it's always, yes, a challenge to find these early adopters, that's for sure. So I wanted to ask you a bit more about your clients. What kind of companies would be your clients? And have you noticed a certain profile of a company being more eager to try these new technologies? For example, are chemical startups more willing to try your product versus a large company?
What we've seen is it depends, but I think where we've had the most traction is a little bit smaller, maybe 1 billion to 5 billion in revenue, which is small for on the smaller side for a chemical company.
But definitely not a startup.
Not a startup. We've seen a lot of those companies because they're big enough that they have large budgets, they have large production assets, but they're small enough that they don't have entire teams working in every single area. And so where we've actually had challenges where you have very large organizations with a lot of experts and people that need to be convinced and vetted, and that just takes so much longer than some of these more nimble, innovative, smaller companies that are willing to just, hey, we don't have time to develop this. Let's buy a product that is out there rather than I'm going to have my team develop it in-house. So that we've had the more success with more innovative, nimble, smaller type companies than some of the larger ones. But that being said, we recently had some strategic investment from Mitsubishi Chemical, which is a top 10 petrochemical company. So we look at them as a very innovative partner in this because they have a venture group. They're looking for new technologies because they know that it can be hard to innovate within these big companies. So they're very specifically making that effort to bridge that and pull that stuff in. So that's been a very, very interesting change for us. And we've navigated that company very well.
And because you mentioned this recent investment, that was going to be one of my next questions. How has it been for you as a startup in this field when it comes to gaining credibility and then based on that credibility, raising funds? Have you found that process to be difficult, and how have you approached fundraising?
Yeah, always, another entrepreneur's challenge, right? Is, raising capital for your idea. So for us, the biggest benefit we had early was the fact that we had a customer, Nalco, do this joint development with us. So we were born as a company with a contract to actually take our product out of the lab into a plant. So that was a phenomenal opportunity and something that we were then able to leverage and build momentum around with investors and say, look, we know there's a market for this. We've gotten these questions a lot of times. We have someone paying to turn this into a product. And then here are all the other markets that we would like to go into. So, the narrative was strong, but it still took time because we had to build the product. It's hardware. We had to install it. We had to prove it. And so then, getting to the point where it was working and then fundraising took time. That was like 3 years. And then eventually we were able to raise institutional venture capital. So we had a financial investor first, Energy Innovation Capital. And that was a long process of getting to know them, work through the network, there was a lot of diligence. They talked to a lot of our customers, and then, they made their investment, and that helped us, have an additional resource, start scaling, and then attract strategic investors like Mitsubishi Chemical and also JSR. So they came in as well.
Yeah, it's always a much longer process, it seems, for startups in this field than it is for most other industries, I'd say. So while this story seems like perhaps exceptional because it took 3 years to get to that point, for us, because we've now spoken to so many startups in this field, it seems like a very normal trajectory. You have to start off, work for years on your initial product, which might not even be ready after 3 years. And then, convince investors of the potential of it, even though you might only have a couple of clients at that stage. And that's perfectly normal. And I think some entrepreneurs might get discouraged by that, but it's definitely the normal thing we see in this industry. And one of my final questions was going to be about your team. So tell us a little bit more about who is in your team. And do you have a technical background as well? Did it take you there after being a child in the lab? Does that mean that you automatically become a technical person, or did you go in a different direction?
I went in a different direction. So one thing I realized was, while I love technology and science, I didn't want to be a scientist or an engineer. So I became very interested in commercialization. How do you get science into a product, which is a very challenging thing to do, because there's tons of great science, tons of great ideas out there in labs that will never get out of the lab. And what it takes is, you have to have an entrepreneur that drives that, pushes it out of the lab, builds the team, to answer the other part of the question. And so for us, spinning out, it was me. I was the entrepreneur, the CEO. My CTO, Mike Drensky, who was working with us in the research center, and he actually was one of the key developers of the technology over the years. So very hands-on, extremely smart, technical. And so that was a very good partnership. So we were the two people full-time in the business. And then my dad was our scientific officer. So, new algorithms, analysis development, he was involved as a consultant. He's still a faculty member. And then the last key component to this founding team is someone with experience. Because to be honest, this is funny. When we were first talking about spinning the company out, I went to Mike and my dad was like, we instead of licensing this out, why don't we do it ourselves? And they were like, my dad was like, I don't think what are you talking about? What does that mean? I was like, I don't know. I'll figure it out. And so, at the time, I didn't really know what I was getting into, but was very fortunate to have some great mentors. So that last piece was our chairman, Bill Bottoms, who's a Silicon Valley guy. He's based out there, he's done venture capital. He's run large technology companies. So, with his guidance, me as a first-time entrepreneur, I was able to make less mistakes. I made tons of mistakes, but was still able to make a lot less because you benefit from someone else's experience. So that's probably the single biggest piece of advice I give entrepreneurs is like, find someone who's done this successfully a couple times and learn as much as you can from them, because your cycles will accelerate tremendously. Otherwise, you have to make every single mistake to get to that point. So
that makes sense, especially if you're a first-time entrepreneur, to find someone that has done it before. So a dream team would be a very smart CTO, a slightly crazier business person who says, let's do it. I don't know how, but we'll just figure it out. A scientist that says, I don't know if this is a good idea, but is very strong in the science department. And then hopefully a mentor or two that have done it before, that can bring you back to earth and tell you how it should really be.
Yeah, and I think that formula works. If you look at companies that spin out of research, you have to have that business plus science and then experience somewhere in there. I mean, you can sub someone in as the CEO with experience too. Mm-hmm. But we just didn't have that available. In New Orleans, there wasn't a lot of people that said, "Oh, I'll come start this company with you." It's like, well, we'll do it and learn.
Well, you definitely have to have someone with experience, but it's also helpful to have someone that hasn't done it and hasn't failed before, so that they're dreamers and they think it can be done. And on this podcast, we usually interview people that have managed to maintain a startup alive for a few years. So these are just the success cases. We don't know how many of them don't make it. So we're just talking now to the ones that do make it. So it's all good. Great. Well, thank you so much for answering all of my questions and explaining how your product works and all that. Are there any last thoughts, questions? Well, not questions, but any thoughts, any wishes you have for our audience? Anything you'd like to tell us?
A few things. One would be, obviously we're always interested in talking to companies, investors, people that want to learn more about what we do. So that's always a very valuable thing to explore. And then, I think, this has been an interesting time with pandemic and now with a lot of social issues in the US. And so, this is a time to look and see where technology can help solve some problems, and have us come together around those things and be open-minded. So be interesting to see how all this plays out.
Yeah.
We're all along for the ride.
That's true. And we're seeing that theme come up quite often now when we're talking to entrepreneurs from all over the world. I feel everyone is a little bit more united in this, trying to make things work better, especially in the current context.
Yeah.
Thank you so much for being with us today. And we'll definitely keep in touch. If we can think of any companies that are in our network that can maybe use your product, we will contact you. And you should also keep in touch with us.
Absolutely. One day I'll hopefully be able to go back to Germany. And then maybe I'll stop by and visit you guys.
Please do. We're in Berlin, very close to the TV tower. So if you pass by as a tourist, you can also stop by our office.
That'd be awesome. Great.
Thanks a lot. Have a great day.
Thank you.
Bye.
Bye.
Thanks for listening to Startup the Science.
If you like our show and want to know more about what we do, check out our website at inam.berlin.
And don't forget to leave us a review. Until next time.